Hello, in this lecture, in continuation to Python programming, I'll be covering a few interesting applications you can develop using normal Python programming. So, to start off with, we'll be covering a few basic operations starting from file read-write operations. We'll be dealing with normal text files as well as CSV files. CSVs are basically comma separated value files. So, each value in the file is separated by a comma. Next, we'll move on to your developing a network socket using Python scripting. So, we'll develop two parts. First, we'll develop a UDP host or a server and a UDP client. And in the third part, we'll be dealing with some basic image read-write operations using Python PIL library. So, to start off with the file read-write operations, as necessary in normal IoT based applications, imagine your sensors or lots and lots of sensors are uploading their data on a particular database or file system. So, the data is separated, separately stored, or data is collectively stored using various timestamps or signatures or identifiers. It may be in a text file for small scale systems, it may be in a CSV file for a bit larger scale systems, and then again for much larger implementations of IoT, people normally prefer using databases like MySQL, Oracle, etc. So, Python allows us the functionality to read and write files. Generally, no external module or library is required. It is available with the basic distribution of Python itself. And while reading or writing a file, three basic steps have to be followed. First and foremost is opening the file itself. Next is reading or writing operation, and third one is closing the file. So, keeping these three in mind, we'll dive into a bit more details about these. So, the open function is used to open a file and returns a file object. That means whenever you give the syntax open, first argument is file name and the second argument is mode. There are the following four modes: R for read, W for write, A for append, and R plus for both read as well as write modes. So, reading from a file, as you can see, the syntax is pretty simple. So, imagine you have a file, text file named data.txt. So, we are going to attempt to open it using this line, file equal to open data.txt comma R. Point to note is both the file name as well as the mode are within quotations, because these are taken as strings. And then in the next line we have file.read. So, this file equal to open function, the file is actually a variable, you can assign any other name to it. Next is the writing to a file part. So, whenever we are writing to a file, again we have to open the file, only the mode changes from R to W. Then file.write, and within arguments you just put in the string you are about to write to the file. You can obviously put various variables, you can store your incoming sensor data in some variable and iteratively write those variables using the file.write function. Now, at the end, once your file access has been done, you must ensure that your file handle is closed by using this function file.close. And whenever, since normally in normal scenarios, especially IoT based scenarios, there is a significant need to iteratively access the same file over and over again. So, using this script with open data.txt in write mode as file, and file.write, we write the string which has to be written to the text file, and then we release the file handle by calling file.close. So, it would be better if we give a bit of hands on to this thing. as you can see, I've already kept the program ready. So we just have to call a file, any file name we want to put. Over here we have Python program.txt. We can change it to something else also. So my files and folders basically reside in this directory. So as you can see, there is no Python program.txt file in this list. So maybe we can just change the name to livedemo.txt. Then in the next line, first we iteratively we have to write something on it. So with open livedemo.txt as w, or in write mode as file, let's call it by another name, file1. Then file1.write, we are writing data abc, and then we release the file handle by calling file1.close. So once we run this thing, so we have executed this thing, these 3 lines of code. Now again we'll check the directory. Here we have the file named as livedemo.txt. We open it. As you can see, the intended data has been written to the text file. So this was part 1, half of the job, that is writing to the file. Next part comes, that is reading from that file. So now I have a file named livedemo.txt. So in the same manner as before, I'll open this same text file but in read mode. So I'll change the mode to R. Initially it was W, now I'm changing it to R. So I'm opening the file mode in opening the file in reading mode, assigning the variable, let us call it file1, or maybe just for the sake of it file2, f equal to file2.read. Then I print reading from the file, and then again I print whatever has been read, and again I release the file handle. I release this file2 by calling file2.close. So once again I'll execute these lines. See, once this execution is complete, the first line has been printed, reading from the file. This was our first print statement. And then if you recall, we had earlier writing data to the text file, like writing data abc. So this has been extracted from that text file and put up and printed on the console. So this was part 1, reading and writing from normal text files. So there can be multiple operations we can consider while doing file read write operations. So not to go into that much details, you can easily avail various resources online to check those. Another common thing being used is this CSV file format or comma separated values. You can again check, I don't have any CSV file in my directory list. So I'm using this script csv readwrite.py. So once this has been executed, it will generate a file with the extension .csv. For this, I have to import an external library or CSV library. once this library has been imported, I define the data I want to write to the file. First I'll write to the file, then once the file has been created and the data written to it, I'll read from that same file. So one point to remember is, whenever I am trying to open a file in write mode, if the file does not already exist, the system will automatically create that file, that same file. So I am giving the file name as output.csv. Let's name the variable as file1. The data is within, since we are putting up a string data, so we are giving 1, 2, 3, 4 up to 9, and we split it using the comma character. You can use other characters also like semicolon, colon, so on, but for the sake of demonstration I am just using a comma. Let's see what happens when I execute this line. So this script has been executed. I'll check what is stored in this. So you can see individually you have various strings separated by comma. The first string is 1 comma, second string is 2 comma, and so on up to 9. So whatever input you had given, it has been individually separated into substrings. Then next I create a variable file1 and try to open output.csv. So in this directory we have nothing called an output.csv file. So we are assigning this output.csv string to variable file1. Now again using with open file1 in write mode as csv file, we call another variable writer equal to csv.writer, and csv file delimiter is comma. Suppose you had given a semicolon as delimiter, you could have replaced this comma by a semicolon, and we print a normal statement to check whether it is working fine or not, and then whatever data is being written into the file, so we call the writer again, and each row we put in a separate value, like 1 in the first row, 2 in the on the second row, 3 on the third row, and so on. Then eventually we call the close function file.close. Now let's see what happens when we run this collectively. So my print statement writing CSV has been executed. Let's check. So the file name was output.csv. Yes, we have a file called output.csv over here. So by default it is opening with Microsoft Excel. So for my system the default CSV file viewer is Microsoft Excel, so it's directly opening through Excel. So it will take some time, let it load. In the meanwhile, we'll look into this writing from a CSV file part. Now again we go on with open, we name a variable file1 in read mode as CSV file, then reader equal to CSV reader CSV file. We print that it is reading from a file, that is, it will just give an indicator to the user that his script is executing, and then for each row being read by the reader, the value being read will be printed one at a time, and eventually we release the handle by calling the file name dot close function. So I have finally managed to open my Excel file. As you can see, the values 1, 2, 3, 4 have been written in separate columns. So instead of these static values, we can acquire data from various sensors, and we can keep on updating this CSV file in an iterative manner. So this will give me a database, a rudimentary database. Okay, now I know my output.csv file is in place. I'll try reading from that file. Now after the script has finished executing, the first print statement was reading from the CSV file, and it has read the values individually, like 1 to 9. So I hope this was quite easy. We'll move on to the next part. So we have already completed these. Now the next part is a bit interesting, since it will deal with various images. So we'll functionally work with image read write operations. Now Python supports this library called PIL, or Python Imaging Library. This is generally used for image related operations. So if by default your PIL is not on the system, we use PIL, or we acquire PIL using sudo pip install pillow. So normally PIL is supported in the Python version 2.7 till 2.7. Otherwise, for higher versions, pillow needs to be installed to get this working. So for image read write operations, first of all, we have to call this PIL library. Either we import PIL directly, or if we have any particular function in mind, like the function image, we just import that particular function. So for that, we have from PIL import image, then opening that image file, image equal to image.open name of the image, and for displaying the image, we just write image.show. So you have multiple functions related to images. You want to resize your image, you call the resize function, and within arguments you give the number of rows and columns. You want to rotate your image, you call rotate, and within arguments the degrees you want to rotate your image. Also, you can convert between various color maps. So for example, you can convert your normal images acquired from standard cameras. We call them as RGB images because of the presence of 3 channels, red, green and blue. We can convert this into grayscale also. So the conversion function is pretty simple, image.convert, and within the arguments, within quotes, you write that mode. L stands for grayscale and RGB stands for the normal RGB mode. So you can alternatively convert between these two. So this is just for the sake of demonstration. See, for example, once we execute this script, we'll come to that in the hands-on part. Once we execute this script, it will give you the following output. The left hand side, this image was taken as the input image, and after conversion using image.convert function, it has converted to your grayscale. So we'll check out this function. So now I have from PIL import image, I'm assigning a variable to the function image.open. So I have a input image i3.jpg in my folder, same folder as the script. Then I execute this im.show. I'll just execute these 3 lines. You see, once the im.show has been executed, the default image viewer application of your system opens up, and this is the input image. Now I'll convert it to grayscale. So im.convert and within quotes L, and again I'll ask the system to show the image. So as you can see, again on the default image viewing application, the image has been converted to grayscale from RGB. Now I need to save this image. So since the converted color map of the grayscale image is stored in the variable gray_image, I need to save this gray_image.save, and the name I want to save it as. So once save function has executed, I get the required file in my directory. These are just some of the very basic functions I can work with. Next, we'll move on to basic networking in Python. So for this, we'll create UDP sockets. So we'll try to simulate 2 systems, like you'll have a client and then you'll have a server. So server will expect data from the client. Later on, you can actually now itself you can actually imagine your client to be deployed IoT devices which read various sensorial data and transmit it over the network to the server. It works in the same principle. So for starters, we'll just see how this networking part happens. So maybe your server is located far apart but connected to the network. Using this same code, same principle, with a bit of modifications, you can get your field deployed IoT devices to send data to a remotely located server. So Python provides this network services using the client server model, and then this socket support in the operating system, it allows the clients to implement servers. It allows the implementation of clients and servers for both TCP/IP, that is connection oriented, as well as UDP protocols, which are mainly connectionless protocols. And Python has additionally libraries which allow higher access to specific application level network protocols. So general syntax is for creating this socket, a variable which is equal to socket.socket, then socket family, socket type, protocol. By default, the protocol is 0. So within socket family, you have AF_Unix or AF_inet. So generally, Unix option is only available for Unix based systems, whereas inet stands for all internet protocols. Socket type is sock stream or sock datagram, and protocol by default it is 0. So we have created a TCP/IP socket. We give the server address as this is a particular IP address, then we give a particular port to which server your client will bind, and just some print statements, and eventually the main function sock.bind and server address, so that this will be listening for connections. And then we have sock.listen. This initializes the listening part, that the server is expecting connections from client. So it would be better if I give a demonstration of this thing. So I'll need two consoles for this. From one I'll run the server, from another I'll run the client. So this is my socket server. For the server address, I have given a normal loopback address, that is 127.0.0.1, given a random port 10,001, and we intend to write the data which is being generated into a text file. So datalog.txt in write mode, and the data socket will be expecting the data which it receives from the client in chunks of 4096 bytes, and whenever this data is received, it will convert the data to string and write the data to the file, and eventually once the transaction has finished, it will close the file. So till this part, the socket operations take place, and within this the data read write operation take place. Similarly, okay, for start I'll get the server running. So it does not show anything because it is expecting data from a client. On the client side, I give the same loopback address as the server, then the same port number. It is very important to have the same port numbers. Now with try and finally, we just iteratively loop again and again and send two values h and t. I've fixed it to 2 and 3, and this will keep on sending these values over the socket. You see this sent equal to sock.send to message, the message that is 2, 3 to the server address that was this loopback address. So in the second console, I'll run the client. You see the client is sending 2, 3, 2, 3. It will keep on sending this until I terminate the execution, and at the server side you are receiving this 2 and 3. So this thing you can implement on two different machines connected to the network. It may be in the same room, it may be in different cities, it may be in different countries, but your server, your IP and port needs to be the same. So we have covered this client, you have seen the code firsthand, and outputs you have seen. So I hope you can now use this knowledge to generate some interesting applications on Python. Thank you.